Okay, so continuing, so from we know now the viscosity, so let's try to solve the Reynolds number. So from our Reynolds number, we have your equation. So for the Reynolds number, RE, so our Reynolds number, so that will be the density of your air multiplied by the D equivalent, then multiply it by the velocity of your duct, then absolute dynamic viscosity. So we have your density of your air. So from kanina, we have solved that one. So that will be 1 point so that will be 1.21, so that will be kilogram per cubic meter. Yan pala magkasya dito. So let's try to rewrite again this one. Kilogram cubic meter, then you multiply it by the D equivalent natin. So we have your D equivalent, that is 0.51 meter, 0.51 meters, then multiply it by the velocity. The value of your velocity is 5.76. So we have 5.76, so this is meter per second. So, then divided by the absolute dynamic viscosity, so we have 18.154 times 10 to the power of 6. So this is Newton per square meter. Then we have second. Then finally we have your Reynolds number, value of, so you have the Reynolds number of 199,033. So this is now, you can say that our Reynolds number is greater than 2100, and the flow is, we can conclude that it is a turbulent flow. So we have the value 199, so plug in natin doon sa natin, sa ating table. So we have 199,033. So type of flow is turbulent. Okay, so pagkasyahin na lang. So we have a turbulent flow. So we have solved the value of your Reynolds number. Now if we're going to plot that one in the so if we're going to plot that one in your Moody's diagram, so turbulent flow, so we'll be using, i-list naman natin, so it is turbulent flow. So turbulent flow, so this will be using a Moody's diagram. So this is the Moody's diagram. So from here, our Moody's diagram we can plot. So but we need the relative roughness. So let's try to compute the relative roughness, where your relative roughness, so relative roughness, so that is equal to your E divided by your D equivalent. So your E, so from here yung roughness coefficient, so we have steel, so that is galvanized, okay, then we use the load, so that will be 0.0002. So this is feet. So we'll try to convert it in meter. Tatambunan pala. Lipatan lang natin dito. So this will be 0.0002. So this will be feet. So 1 meter is 3.28 feet. Then divided by our D equivalent. So from our D equivalent kanina, so that is 0.51 meter. So we have the value of 0.51 meter. Then our relative roughness is equal to, so we have the value of 0.0001. So if we're going to plot that one, 0.001, so ito yon. So we use the red. So we have here 0.001. Now the Reynolds number, so can be expressed as, so 1.9 times 10 to the power of 5. So this will be 1.9. So it can be here. So let's put it here. 1.9 times 10 to the power of 5 ang value ng Reynolds number natin. So it can be expressed as 1, 2 decimal, 5 decimal places, 1, 2, 3, 4, and 5. So to be checked. So we have now the value. So if we're going to plot that one, so we draw as a shape for this one. So from here, okay, so straight line path here, then also with the corresponding here. So then straight in here, okay, so we have the value. So with the corresponding line, so here, so we have 0.025, so that is in between, so that this is really around that can be 0.027, okay? 0.027, the value of your friction factor. So this is now your F value, okay? 0.027. So plug it in here in our table. So we have 0.027, the value. So solving for the pressure loss for the straight duct, so we have now, so change in pressure, so that will be F, we have L, D equivalent multiplied by the velocity squared over 2 times your density of your air. So this is 0.027 multiplied by the length of the duct, so that is 1.6 meters. So we have 1.6 meter divided by your D equivalent on the table, so 0.51, or so we have 0.51 meter, then multiply it by the velocity of the duct running there, so 5.76. This is 5.76 meter per second. So this is square raised to square. Divided by 2. Then the density of your air, this is equal to 1.21. So finally we have your pressure drop equal to, okay, so finally we have the value of 1.7. So the units, so cancel out. We have to cancel yung to check our units. So this is cancel. So we have here kilogram. So this will be kilogram. Ang units natin maiwan is kilogram, cubic meter. Then multiply by meter squared, second squared. Okay? So this can be expressed as breakdown, kilogram, meter, second squared, multiply by meter divided by cubic meter. So this is already in Newton, and this is now square meter. Okay. So we have Pascal to be exact. We have now Pascal, 1.76 Pascal. So we have the pressure drop here, so loss per item. So we have, we'll put here, this is 1.76, 1.7 Pascal. It's the pressure loss.